Good morning, students. How are you and how was your night? Yeah, this morning we'll continue from where we stopped. We are to use integrating factor to integrate first order differential equations, right? It's okay. So let's proceed further to continue with the integrating factor. Is that clear? We continue with the integrating factor. Okay. So far, so good. Our integrating factor using the integrating factor. The formula is y exponential integral e dx is equals to integral exponential p dx then q dx, right? And the differential equation, that y over dx plus py is equals to q. So far so good. This is what we are going to use to integrate this type of first order differential equations. Please try and share the link with those who are not around. Okay. Please, I want you to like. So let's proceed further to consider one or two examples. Is that clear? Let's proceed further to consider one or two examples. Amen? Okay? Okay. Solve a differential equation. Example, solve 1 all over x dy all over dx plus 4y equals to 2. As simple as ABC. So at first what you need to do is you have to transform this differential equation into this form, the way this one is. Is that clear? This dy over dx plus py equals to q. Are you following? So now what we need to do is let's write solution, right? 1 all over x dy all over dx plus 4y equals to 2. So at this point, when you come across something like this, you take LCM, right? The LCM here is x. So this value to be x to x, 1 times 1 times dy over dx is dy all over dx, then plus x to 1, x times 4y, 4xy, then this will be equals to 2. So now we cross multiply, right? So when we cross multiply, we are going to have this one to multiply the left hand side, x to multiply the right hand side. We are going to have dy all over dx plus 4xy equals to x times 2 is 2x. Can you see now we have transformed this first order differential equation into this form? Can you see now? Are you feeling? So far so good. So this implies that we have to equate it with this. We have P y equals to, this is 4xy, true or false? Then our q is equals to what? Is equals to q is what? 2x, right? Okay, so this and this will go. So our p will now be 4x and q is 2x. So what we are going to do, we have to substitute this into this formula, this integrating formula. Do you agree with me? Any question, please ask. Do you have any question? Oh, somebody is asking me to take it again. Amina, it's okay. Let me take it all over again. You understand that this is the formula for integrating factor. Then, for you to use integrating factor, it means your differential equation must always be in this form. But look at it. We have a question here. Solve 1 all over x dy over dx plus 4y equals to 2. Looking at this equation is not in this form. Why? Because of this 1 all over x. True or false? Here, there is nothing like a coefficient. True or false? There is nothing like a, there is nothing like 1 all over x. True or false? Plus py equals to q. So, as it is, this first order differential equation, it is not in order. So we have to put it in order. How? We have to look for the LCM of this and this. Is that clear? And the LCM of x and 1 is x. So x to x, 1. And that is x divided x. That is what it means. X to x is 1. So 1 times 1 times dy all over dx. It will give you dy all over dx plus x to 1. X divided 1 is x. Times 4x, we are going to have 4x equals to, what is here? 2. Then this, at this point, we have to cross multiply. Mind you, there is an invisible one here, right? 2 all over 1, then this all over x. So when you use this one to multiply dy all over dx plus 4xy, you are still going to have dy all over dx plus 4xy equals to, if you use x to multiply 2, you are going to have 2x. Do you agree with me? Then you now come back to where you equate this differential, first order differential equation to this one. That is what I mean, is that you equate it this way. Our dy all over dx. Here we have dy all over dx. True or false? Then here we have py. So here is py equals to, here what we have? 4xy. 4xy. Then here we have q, which is, we have 2x. So you can now see that q is equals to 2x. This y and this y will cancel to give us our p equals to 4x. True or false? Because in the formula, there is nothing like py, it is only p. True or false? Any other question, please? Do you understand? Do you understand? Any question? Is there any question? No. So we can proceed now, right? Can we proceed? Yes or no? Can we proceed? Yes or no? Oh, Kenneth, thank you. Okay, let's proceed, right? So far, so good. So, as you can see now, we have to substitute. I think I can clean this. Let's substitute in this. But since the formula is y exponential y integral p dx equals to integral p dx times q dx. So if I were you first integrate this. That is our integral p dx is equals to integral. What is our p? Our p here is 4x, right? 4x, right? So when you integrate 4x dx, sorry, yeah. So when you integrate 4x, you are supposed to have x 4x raised to the power 1 plus 1 all over 1 plus 1, which is equals to what? 4x raised to the power 2 all over 2. Then this is the same thing as what? 2x squared, right? True or false? It's true, right? It's okay. Let me write our 1 all over x dy all over the x plus 4y equals to 2, right? Okay. Do you agree with me? Yes. So, any question here before I proceed further, please? When you integrate that, that is what you are supposed to have. Okay? So we can proceed, right? Let's proceed further. Okay? So far so good. So it will be easier for us to substitute in y exponential instead of integral p dx. Already we have gotten the answer. Exponential what? 2x squared equals to integral, instead of exponential integral p dx, we write exponential 2x. Then what is our q? Our q is what? 2x times 2x dx. True or false? Do you agree with me up to this step? Any question? Do you have any question? Please ask. Any question? Any question, yes or no? Oh, Khalifa, Aminu. The second step, okay. What? Okay, look at it. Look at it. Let me clean it. Look at it. This is the formula, true or false. Already we have gotten integral here, p dx, which is what? Equals to 2x squared, true or false. So there is no need for you to rewrite this again. So what you are going to write is y exponential integral, our p dx, look at it here, gives us this result, 2x squared, then equals to integral exponential, our integral p dx gives us this 2x squared, then our q here, this is our q, this is what? 2x times 2x dx. Do you agree with me? Do you agree with me? Hope you are following, right? How Buhari Sani, how do I get the 2x? Yeah, we got it from here now. Look at it. Look at it. We integrated it. What is your p here? Look at it. Your p, look at it here. P integral p dx will now be equals to integral. What is your p? Your p is 4x. 4x dx. So it is left for you to integrate this function. When we integrate this function, Mind you, there is an invisible one here. You are going to have x raised to the 4x raised to the power 1 plus 1 all over 1 plus 1. Alright? So this will give you what? 4x raised to the powers of 2 all over 2. Right? Yeah. 4x raised to the powers of 2 all over 2. So 2 to itself 1. 2 to 4 is 2. It's going to give us 2x squared. That is why we have this. Worry? Are you following? Are you following? Yes or no? So we can proceed, right? Okay, so let's proceed. So now, at this point, what we need to do, we are asked to find y, and y will give us the general solution. Okay? So let's first consider the right hand side. As you can see now, this right hand side, we have exponential 2x squared times 2x dx. So what we need to do, we are going to, that is to obtain integral exponential 2x squared times 2x dx. We apply what is called integration. We apply integration by parts. Integration by parts. So that is, here with integration by parts is the formula is u dv will now be equals to uv minus integral v du. Just like your product rule. Yeah. Just like your product rule. Do you understand? So you just here, what you will do here is you now let's look at it. Let u be equals to 2x and the v equals to exponential 2x squared dx. Is that clear? Look at the board. Exponential 2x squared dx. Right? Exponential 2x squared dx. So far so good. So we have to differentiate this with respect to x and integrate this with respect to x. So our du all over dx is equals to, when you differentiate 2x, you have 2. Then you now, to obtain du, you cross multiply. It means our du will now be equals to 2 dx, because when you cross multiply, then here, if you integrate the v, you are supposed to have v. But this right hand side, you are going to use substitution method because of 2x raised to power what? Power 2. So you now see, let p be equals to 2x squared. So our dp all over the x is going to give us 4x, right? So far so good. So therefore our dp is equals to 4x dx. Amen? Do you agree with me? 4x dx. Is that clear? Do you agree with me? Look at the board. Please look at the board. Amina is not clear. Okay? Look at the board very well, please. Look at the board very well. Or let's do it this way. Let us do it this way. Right? Let's do it this way. It's okay. Okay. Let's do it this way. If you can see what I am saying, here will now be here will now be 2, okay, let's say let u be equals to exponential 2x, then the v be equals to 2x dx, then our du all over dx is going to give us, 2x squared, going to give us 4x exponential 2x squared. Then the u will now be equals to 4x exponential 2x squared, 2x squared dx. Then our dv, when you integrate, we are going to have v equals to 2x raised to power 2 all over 2. Then this is equals to x squared, right? Yeah. So instead of this, let's do it this way. You understand what I did? I tried to change let u equals to exponential 2x squared, then the v equals to 2x dx. So when you differentiate exponential 2x squared, just assume that this is how it is. So if you differentiate 2x squared, you are supposed to have what? 4x, right? So use it to multiply the function back to 4x times exponential 2x squared. Two of us. So, okay. So if you can see what I am saying, we have to substitute this into the formula, that is integral exponential 2x squared times 2x dx is equals to, what is our ordinary u? Ordinary u is exponential 2x squared times, what is our ordinary, that is ordinary v. Ordinary v is x squared, right, minus integral, what is our ordinary v? X squared, then our du is 4x exponential 2x squared dx, right? Yeah. True or false? So this will going to give us x squared exponential 2x squared minus integral, this times this, going to give us 4x cubed exponential 2x squared dx. Is that clear? So we are still going to use integration by parts. We are still going to use integration by parts there, because we still have two functions here. We are still going to use integration by parts here. We have two functions here. So we can now say let u be equals to exponential 2x squared, then the v be equals to 4s cubed dx. So when we differentiate our d all over dx, it's going to give us 4x exponential 2x squared. Then what we are going to have here is our du is equals to 4x exponential 2x squared dx. Then integrate both sides. The v, you are going to have v, then if you integrate 4x cubed dx, we're going to have 4x raised to power 4 all over 4, right? This cancels to give us 4x raised to power 4. True or false? It's true, right? True or false? It is true, right? I'm not going to finish it though. You'll be the one to finish it. You'll be the one to finish it. Yeah. You'll be the one to finish it, and that will be your assignment. So go and finish it to have, at the end of the day, this is what you are supposed to have: y exponential 2x squared equals to 1 all over 2 exponential 2x squared plus any constant. This is what you are supposed to have. So I want you to, it is an assignment, I want you to go and finish it. Is that clear? You go and finish it. By the time you integrate as use the what is it called, integration by parts, then you are going to you substitute in, then you cancel. At the end of the day, that is what you are going to get. But do it. I will do it in class. You finish it. I will do it in class. Is that clear? Yeah. Shadrach, I said you people left as what? Assignments. That is what I'm saying. I said I'm going to do it in class before we continue our lectures. So let's go ahead to consider more problem. Is that clear? Okay. Yeah. I said I will do it in class, but I want you to finish it. I've written the answer. So go and look at it again and again. Amen. So let's consider another example. Determine the particular solution of another example. Determine the particular solution of dy all over dx minus x plus y equals to 0 given, amen, given x equals to 0 and y equals to 2, right? Oh, sorry, when y equals to 2, as simple as ABC. So let's fix idea with this example that we are about to do. Please take note of this example. It's very important. Is that clear? I said what? Take note of this example. Very, very important. Okay, so far so good. So let's write a solution. That is, we are using integration by integrating factor by integrating factor, right? It means our y exponential integral p dx is equals to integral exponential integral p dx q dx, right? Then we need to transform our differential equation dy all over dx plus p of y equals to q in this form. But looking at this differential equation, we have dy all over dx minus x plus y equals to 0, right? Two of us. So we have to transform it in this form. So you don't need a prophet to tell you. By the time this minus s crosses the sign of equality, it becomes in this form. So our dy all over dx plus y equals to x. Can you see now? So this implies that we have to equate it, right, with this. Our py is equals to y and q is equals to what? X. True or false? So this implies that y cancel y, our p will now be equals to 1. True or false? Yeah. Then q is this. So we have to recall the formula. Do you understand up to this point? Please look at the board. I said take note of this question. It's very important. Take note of this question. Take note of this question. It's very important. Okay. Any question? Abdullahi. Okay. Course rep, evening. Julius. Okay. So far, so good. What we need to do is we have to substitute this into, let's recall our integral p dx, which is equals to, what is our p? P is 1, right? So integral 1 times dx is the same thing as integral dx. So if you integrate dx, you are going to have x, true or false? Yeah. So it implies that we have to substitute this into this formula, then our q into this formula. So here we are going to have y exponential x equals to integral exponential x dx, right? Yeah, hope I'm right, because our q is what? X. So q times our integral p dx is x, true or false? So here we are going to use integration, that is by parts. We will make use of by parts again. This right hand side using by parts. By part, that is integral u dv is equals to uv minus integral v du, right? Okay, do you agree with me? So this is our u is, let u be equals to x, and the v, our dv be equals to exponential x dx. When you differentiate this function, you are going to have 1, true or false, equals to 1. Then you must make u the subject of the formula. You cross multiply. Our du is equals to 1 times dx is dx. Then when you integrate the v, you are supposed to have v equals to, if you integrate exponential x dx, you are still going to have exponential x. Is that clear? That is how it is. Do you understand? Do you understand, right? That is how it's supposed to be. So we have to substitute this and this into this formula. So therefore we have integral u is what? X. Then the v is exponential x dx equals to uv. Our uv is our ordinary u is x. Then our ordinary v is what? Exponential x minus integral ordinary v exponential x. Then du is dx. True or false? Yeah. So this implies that this gives us this. True or false? So we now write our, amen? We now write our y exponential x is equals to x exponential x minus integral exponential x dx. For the fact that integral still exists, it means we are still going to integrate this part. So when we integrate exponential x dx, we are going to have exponential x. Take note. So far so good. Y exponential x is equals to x exponential x. Then when you integrate, minus exponential x plus any constant, either k. Is that clear? Are you following? Take note of this question. It's very important. Okay. So far, so good. So let's recall our boundary conditions. They said given x equals to what? 0. And to obtain the particular solution, then when y equals to 2. So anywhere you see x, you substitute it 0. Anywhere you see y, you substitute it what? 2. So here will now be 2 exponential what? Here will be 0 equals to here is 0 times exponential 0, right? Minus exponential what? 0 plus a. True or false? So this is anything raised to power 0 is what? 1, right? So 1 times 2. 2 equals to, this is 0, so 0 times exponential 0 is 0. Then here will be what? 1, isn't it? Yeah, because exponential anything raised to power 0 is 1, so here will be minus 1 plus k. So our k, we collect like terms. Here will be 2 plus 1. Therefore, k is equals to what? 3. True or false? K is equals to 3. Yeah. So far, so good. Any question? I will still explain it in the class. So don't be panic. Buhari is asking me to come again. It's okay. Here. Where? I said at this point, we have 2 functions here. As long as integration is concerned, if you have 2 functions, the first thing you should think is the rule you are going to apply, the method you are going to use in integrating this type of function is what we call integration by parts. And integration by parts, the formula is u integral u dv equals to uv minus integral v du. Is that clear? So you don't need a prophet to tell you. This is the function, right? So you now say let u be equals to x, the v be equals to exponential x dx. So at this point, you have to differentiate this function with respect to x. If you differentiate this function with respect to x, your du all over dx is 1. Then in the formula, we have du, true or false. So you have to make du the subject of the formula. By the time you cross multiply du, it means this is how it will be. 1 all over 1 times du is du. Then dx times 1 is dx. Can you see now? So now we have to get obtain ordinary v. How can we obtain ordinary v? For us to integrate both sides. If you integrate the v, you are going to have v. Then if you integrate exponential x dx, you are going to have exponential x. Yeah, you may ask, why not plus constant? It is not necessary. Why? Because you are using integration by parts. Is that clear? That is why you are not saying the constant. Is that clear? Okay. So that is that. So now you substitute it into this formula. This is our ordinary u. What is our ordinary u? X. Look at it here. What is our ordinary v? Look at it here. Look at it here. See it here. Look at it here. Now what do you have? Minus integral. What is ordinary v? Is exponential what? X. Look at it here. Then what is your du? Your du is the x. Can you see it? So now, as it is, we obtain this. We obtain this from here. So we have to write y exponential x. See it here. Y exponential x equals to this gives us this result. True or false? Write x exponential x minus integral exponential x dx. So at this point, Since we still have integral sign here, we have to integrate what is inside there again. So when we integrate exponential x dx, this is what we are supposed to have plus the constant. Can you see now? But we have been given what? Boundary conditions. That is x equals to 0 when y equals to what? 2. So we have to substitute in anywhere we see x and y to obtain our particular solution that we are going to first obtain the constant. So now when we substitute, you can now see that k is equal to 2 plus 1. Then 2 plus 1, k is equal to what? 3. So our particular solution will now be, amen, will now be, instead of k, we write 3 here, will now be y exponential x equals to x exponential x, then minus exponential x. What is your k? 3 plus 3. This is how it's supposed to be. Any question, please? Do you have any question? Or there is another way we can write that question. Hope you understand, right? Okay. Any other question? Do you have any other question? Okay, let's look at this. Let us look at this. Solve the differential equation. Solve the differential equation we have dy all over the theta then equals to sec theta plus y tan theta. Then given the boundary conditions, that is y equals to 1, then when x equals to 0, theta is not x, theta equals to 0. Amen. So let's look at this problem. Let us look at it together. It's simple as ABC. As simple as ABC. Okay. So far so good. At first, you consider the formula y exponential what? P d theta. Since there is no x here, the theta now equals to integral exponential P d theta then times q the theta. Since the independent variable is theta, right? So take note. Is that clear? So please listen very attentively. It's very important. Is that clear? Okay. So far, so good. So let's proceed. Let's proceed. Let us proceed. So we have to recall the differential equation of this form plus P1 equals to Q, right? So we have to transform this differential equation dy all over the theta equals to sec theta plus y tan theta. Amen? Okay? So if you agree with me, you don't need a prophet to tell you, let's transform this differential equation into this form. How? By the time we bring this one to this side, this is how it's supposed to be. Theta minus, right? Y tan theta equals to what? Sec theta. Amen? True or false? True or false? Then let's equate it with this. It means our P is our P1 is equals to minus y tan theta, right? Then our Q, you don't need a prophet to tell you, sec what? Sec theta. So this and this will cancel to give us P equals to minus tan theta. True or false? Look at the board. True or false? True, right? It is true. Okay. So far, so good. What we need to do is, let's recall this. Integral P d theta is equals to integral minus tan theta d theta. True or false? So when you integrate tan theta, you are supposed to have in, but there is minus in sec theta. Is that clear? Is that clear? Minus in sec theta because of the negative sign. Is that clear? So now, that is how if you integrate tan theta, you are going to have in, but supposing there is no minus here. If you integrate tan theta, the theta, you are supposed to have in sec theta. Take note. Is that clear? But for the fact that there is minus here, it will be minus in sec theta. Now, here, let's go back to our, what is it called? Our logarithmics. We are taught log, both first semester, even in differentiation. True or false? You know, when we have log of log n log a, we can rewrite it in this form, log a raised to the powers of n. True or false? Then, if assuming we have minus log a, we can rewrite it in this form, log a raised to the powers of minus what? 1. Take notes because we are going to somewhere. So now we have in minus in sec theta. So this is the same thing as, we can rewrite this dot in this form, in open brackets, in open brackets, sec raised to the powers of minus what? Yeah. True or false? True or false? Look at the board. True or false? It's true, right? It is true. Yes, it is true. So this implies that you now go back to your trig identity. When we have 1 all over cos theta, this is equal to what? Sec theta. So if now we have sec, this is sec theta inverse, it means this will be just like when you cross multiply, you are going to have this times this will make sec theta inverse. You are going to have 1 equals to cos theta times sec theta, then make cos theta the subject. By the time you divide through by sec theta all over sec theta, you are going to have 1 all over sec theta, which is equals to what? Cos theta. So it means this is the same thing as sec theta inverse is equals to cos theta. So I want to do something. Take note of this. Is that clear? Are you following? Okay. So let's proceed. Let us proceed. So this implies that this will now be our minus in sec theta is the same thing as in open bracket sec theta raised to power minus 1. Then this is the same thing as in what? Cos theta. Can you see now? So let us substitute this into this formula. Let's substitute. Right? This is y exponential our p d theta is in cos theta, then equals to integral exponential in cos theta, then times q is what? Sec theta, right? Sec theta d theta. Do you understand? Amen? Okay, so far so good. So here, I just try to use here as so here will now be y exponential in cos theta equals to integral exponential in cos theta times sec theta d theta, right? So when you have in exponential, let me say x, this will cancel, so you are going to have x. Take note. So here will now be y cos theta equals to the same thing, integral cos theta times, let's come back here, sec theta is the same thing as 1 all over what? Cos theta. So instead of sec theta, we write 1 all over cos theta d theta. Amen? So this and this will cancel. Remember 1 theta. Remember 1 d theta. So far so good. Here we are going to have y cos theta is equals to 1 times dx integral d theta. Y cos theta is equals to, when we integrate the theta, we are going to have theta plus any constant c or So we now consider the boundary condition when y equals to 1, when theta equals to 0. So far, so good. So you don't need a prophet to tell you. So our y cos theta is 0, right? 0 equals to 0 plus c. Sorry, y is what? 1, right? So 1 times this, cos 0 is 1, two of us. So our c is equals to 1. Our c is equals to 1. So the final answer now, will now y, the particular solution cos theta is equals to theta plus c, the constant is 1. So this is how you are going to solve this type of problem. Is that clear? This is how you are going to solve it. This type of problem. Is that clear? Do you have any question? So far, so good. Thank you for your time. Our time is up. So we'll call it a day at this moment. Thank you and God bless you. And don't forget to share. Love you guys. I will explain this in class. Just keep your question. Bye. Yeah.